Okay, so remember, this A is this. AX squared plus BX plus C. This is what we call the general form of a trinomial. It starts with a quadratic term, then there's a linear term, then there's a constant term. So you guys already know what to do when A is 1. That's what we just did, that whole page, right? So just to remind you, we've got it right here, right? If I expand this, I get x squared plus 4x plus 6x plus 24, which gets me x squared plus 10x plus 24. And then if I ask you to factor this, you can see that A is 1 in this case, right? So all we do is we got to multiply to 24 and add to 6. And you get, or add to 10. And you get x plus 4 and x plus 10. Everyone's cool with that, right? The regular factoring, yeah? Yeah? Okay, now, the new stuff is here. Since this is a binomial, and we're multiplying by another binomial, these guys are the factors, yes? Right? So when I expand it, I'm going to get 6x squared, right? Minus 4x plus 3x minus 2. Everyone's cool with expansion, right? I'm marking your quizzes right now. Most of you are pretty good at it. Everybody's cool with that, right? And your final answer will be 6x squared minus x minus 2. Everybody cool? Right? Now, you guys are smart kids. When I say factor that, you should look at that and say, okay, it's definitely a trinomial. It's got an x squared just like this, right? The only problem is it's got the 6 in front of it. I know how to get rid of the 6. I divide by 6. Oh, but wait, 6 doesn't work here and here, does it? So I can't GCF it. So then I think to myself, okay, there must be a way to factor this out, possibly. And I know about this move. Now, you guys are smart. You should notice when you look closely at the original factors, which are right here, and at the expanded form, you should notice some similarities. What do you see? What do you see there, there, and there? 2 times 3 makes 6, right? What do you see there, there, and there? You guys can't see a relationship between plus 1, minus 2, and minus 2. 2 times 1 is 2. So, just like up here, I had to multiply to 24, didn't I? Right? Everyone agrees? So, there is something important about this last term. Yeah? Always. Now, you also will notice the only difference here is this was a 1, correct? Everyone with me? How much bigger is that than 1? What did I have to do to x squared to get it to 6x squared? times by how much? 6. Everyone cool? Okay. Now, you guys are smart kids. If there's a rule when this is 1, and there's going to be a rule when 6 is there. If I had to multiply this by 6, right? What do you think I got to multiply this guy by to follow the rules? 6. Is everybody cool with that? So the only difference, I said there's one difference. There's one new thing to this. The only thing you got to remember is when it's 1, the 1 and the 24 are going to work together. When it's 6, the 6 and the 2 are going to work together. Okay? That's the only new thing. Everybody cool? All right. So I'm going to show you how to do this now. Now listen to me. We missed 8 days of school. Normally I take 2 class periods to show this because I show you why it works and I show you 3 different ways to do it. One of them is super easy, but not very mathematical, like you just follow steps. The other 2 have math involved, which are actually better for using, but not better to get the right answer. Do you follow the difference? Okay. Normally, I don't like to interrupt. It's super rude. Normally, I show you guys the why of something, so you can then apply it everywhere. But this why takes a long time, and we lost a lot of time. So I'm cutting straight to the shortcut, okay? I'm going to show you why it works in a minute, but I'm not going to make you write it down. So you'll believe me that the shortcut works. Understand? Okay. So we are going to take this thing and we're going to factor it. We already know the factors, don't we? But let's pretend like we don't. Cool? All right. So we are starting with, now this is what I want you to write down. We are starting with 6x squared minus x minus 2. Now you guys are smart kids. You know that if there was no 6 there, I would be multiplying to 2, right? Right? But there is a 6 there. So I have taken my 1 and multiplied it by 6, haven't I? Which means I'd better, since if there was no number there, I would be working with 2. But since I've multiplied this by 6, what do I have to do to this, do you think, so I can work with it? I got to multiply it by 6. So I go over here, and now I got to multiply to negative 12 and add to negative 1. That part doesn't change. Everybody cool? So, what are the numbers that multiply to negative 12 and add to negative 1? Positive 3 and negative 4, right? Oh, I thought you said negative 3 and negative 4. Okay, my fault. I misheard you. So, we know that this is going to be x plus and x minus, don't we? Because this is negative, right? And we know it's got to be plus 3 and minus 4, right? So far, everyone's with me, yeah? Because this is nothing new. Now we come to the one new thing. What did I do here? I multiplied by 6, yeah? We're factoring, aren't we? And don't I need to do some division to do some factoring? Have I done any division yet? No. So here, I got to divide by 6. Because I multiplied by 6 at the beginning. I haven't gotten rid of that 6 yet, which is the goal of factoring, isn't it? So I divide by 6. Now think back. Would you ever, in grade 3, when you were learning fractions, leave a fraction that looked like that? What would you write it as? What? A half. Would you ever leave a fraction that looked like that? What would you write it as? 2/3. So now I have this, x plus 1/2 and x minus 2/3, don't I? Does everybody see that? Everybody sees that? Everyone's got that written down? Okay, now I want you to stop for a second and just watch. That's what we had, yes? Everyone agrees? In our class right now, what would you do with that at this point in your math education? When you see two binomials lined up like that, what do you automatically want to do? FOIL. Let's do that. Everybody cool? Don't write it down, just watch. This is the proof of what we just did, because what we just did is ugly, right? It doesn't look like it's going to work. What's x times x? X squared. What's x times negative 2/3? Negative 2/3 x. Cool? What's 1/2 times x? Plus 1/2 x. Cool? And finally, what is 1/2 times 2/3? I'll help you out. Negative 2/6. Agreed? Everyone agree? Okay. Everyone's cool? So what I have there is x squared, and I got to combine these like terms, don't I? Which is 1/2 minus 2/3, yeah? 1/2 is 3/6, agreed? Minus 4/6, which is negative 1/6, yes? So I have x squared minus 1/6 x minus 2/6. Does everyone agree that that is what that FOILs out to? Yeah? What do you, as teenage math students, hate about that trinomial? Fractions. We hate fractions. How do we get rid of them? How do you get rid of divided by 6 and divided by 6 in algebra? You multiply by 6, don't you? So if I multiply this whole thing by 6, what am I going to get? What's that? 6x squared. What's that? Minus 1x, right? Because the 6's cancel, agreed? And what is that? Minus 2. Cool? Does that look familiar? Does it? How? Where have we seen it? It's what we started with. Is everybody cool? So we know this is going to give me this. But this is ugly, isn't it? So here's what you do. And this is the only time I'm going to do this for you. I'm not going to get into why this works. Once you get to here, please notice there's a 2, there's a 2. There's a 3, there's a 3. Where do the denominators go? To the front. 2x plus 1 and 3x minus 2. Does everyone see? It is nothing new until here. You make a fraction with whatever that was, simplify it, and move the denominators to the front. And the reason it works is right here. This will be recorded on YouTube because most of you didn't write that down like I told you not to. I just wanted you to pay attention because dealing with the fractions messes you up, right? I just wanted you to see it. So now I want to do one of these. Actually, we got quite a bit of time. We're going to do a bunch of these. We are not going to do number one because number one's numbers are too big. Okay, I'm going to leave number one for you to try. We're going to go straight to here. So this is how you approach your factoring questions. I look at that and I say, okay, it's a trinomial. There's something I can do with it. What don't I like there? I don't like the 3. Can I divide that 3 out? No. So I got to do this new thing. If that was just S, no problem. I got to multiply to 10 and add to 13, right? But it's not S. It's 3S. So that's been multiplied by 3, right? So I take that 3 and I got to multiply it by the other thing that I care about. So now I need to multiply to what? Negative 30. And I need to add to what? Negative 13. Now everybody wants to say it's 10 and 3, but it's not. Because I got to multiply to negative 30. So I'm going to help you out because this is a tricky one. Everyone forgets this one. It's plus 2 minus 15. Everybody okay with that? Now, have I dealt with this 3 yet? I've only multiplied it. I'm trying to factor. I haven't divided it out yet. So now I divide it out. Now I see fractions. Do I like fractions? No. Simplify them. Does that simplify? No. So where does the new denominator go? Out to the front. 3s plus 2. Does that simplify? He waited expectantly for grade 10s to tell him what 15 divided by 3 was. 5. Any denominator? No. So it's s minus 5. Now let's check. Is 3s times s 3s squared? Yes. So our s and our 3s are right. Is 2 times negative 5 negative 10? Yes. So those two are right. If those two are right and those two are right, the middle takes care of itself, doesn't it? We just proved that earlier, right? With the x squared thing. Is everybody cool? All right, let's try the next one. We're going to work through... I'll get it! Go for Myers. Nope. And often isn't. Okay? Bye-bye. Okay. Remember, you guys know every step you have to take. And I watch you when you do these. And you get to something that you don't like and you sit there. Then I come over and I say, what would you do next? And you say something. And it's usually right. Understand the problem here. Why would you sit there staring at a piece of paper when I come over and I say, what would you do? And you say, well, I'd like to try this. And you do it and it's right. Why wouldn't you just do it? Do you understand what I'm saying? What's the worst that can happen if it's the wrong thing? You get out an eraser and you try something else. Right? Is the world going to blow up? No. Are you going to fail? No. There is no stakes here at all. This is your practice work. There is no stakes here. So just try it. So I look at that and I say, self, what do I want to do with that? What don't I like? I don't like that 6. So I'm going to try and get rid of it. Can I divide everything by 6? No. But look closer. Can I divide everything by something? By 3. So I'm going to divide everything by 3, which gets me 3, 2x squared minus 7x plus 3. Now I'm stuck, aren't I? Right? Okay. So I know what to do if that's an x, but it's not an x. It's 2 times bigger than x. So if that was 1x, I would be working with 3, but I'm not working with 3. I'm working with 2 times 1, so I must be working with 2 times 3. Agreed? So I got to multiply to what? 6 and add to what? Negative 7. What is it? Negative 6 and negative 1, right? Now, what have I done in the first step that I haven't fixed up in the second step yet? I haven't done my division yet, right? So I divide by what? 2. And then I simplify. Does that get any simpler? 6 divided by 2 is 3. Does that get any simpler? No. So the denominator goes to the front. And my final answer is x minus 3 and 2x minus 1. And then I check. Except there's a 3 in front of it, right? Don't forget that 3. Is x times 2x 2x squared? Yeah, sure, you betcha. So the x and the 2x are right. Is negative 3 times negative 1 positive 3? Yep, so those two are right. And then I already know that 3 is going to work because I'm the one that took it out. Got it? All right. Let's look at 4. Can I do anything with that at the beginning? It looks snaky. Can I do anything with it? No, I can't make it any simpler, so I got to work with it. If it was a p, I would know what to do. I would be multiplying to 5, but I'm not multiplying to 1p. I'm multiplying to 8p. So I got to remember that this 8 has to go over here, which means I am multiplying to what? What kind of 40? Negative 40, and adding to what? Negative 18. So what is it? Is it 1 and 40? Is it 2 and 20? Yeah, because 2 and 20 will get me to 18, won't it? How? I need negative 18, so I must need negative 20 and positive 2. Now, what did I do with this 8? I multiplied it. So what do I got to do with it now? Divide it. And then I simplify. Does that simplify? Into what? 5 over 2. Does that simplify? Into what? 1/4. Is there a numerator and denominator left over? Yep. Denominator to the front, 2p minus 5. Denominator to the front, 4p plus 1. And then I check. What's our check? Is 2 times 4, 8p. Yep, so they're right. Then I check here. Is negative 5 times positive 1 negative 5? Yep. And if the edges work, the middle works, as we proved last page. Everybody good? Now, do you see what I mean? How it's exactly the same thing, the same methods? The only thing we did differently was what actually makes perfect sense, doesn't it? When the A was 1, we knew what to do. But in these cases, A isn't 1. It's 24 times bigger than 1. So everything we're going to work with has to be 24 times bigger, yeah? That's it. That's the only difference. Okay? All right. So speaking of, what are we going to do with 5? It's yucky. What makes it yucky? 24 is a big number. So if I just go ahead and start, I got to do 24 times 24. That's a huge number, isn't it? But if I look closer, I can make that simpler, can't I? How? Divide by 2? 4. So 4, and then I get 6h squared minus 5h minus 4. Now it's super easy, right? What do I got to multiply to? I'm not even going to draw the arrow in. Negative 24. And what do I got to add to? Negative 5. What is it? If you don't see it immediately, what should you do? Start with the factors. Is 1 and 24 going to get me to 5? Oh, of course it should be a 6. Moron. But regardless, so I am multiplying to negative what? What am I multiplying to? Negative 30. So what is it? Yeah, 36. What am I multiplying to still? What are the factors at 36 that can get me to 5? Is it 1 and 36? 2 and 18? 3 and 12? 3 and 12 will get me to 5? Is it 4 and 9? Yes. I need negative 5, so it must be plus 4 minus 9. Yes? What's my last step? Divide by what? 6. And then as soon as you see that, Mrs. Bad Crumble thinking takes over. Simplify fractions. 2/3, 3/2. 4, 3h plus 2, 2h minus 3. And then I check. Is 3 times 2 6h? Is 2 times negative 3 negative 6? So we know we did it right. Good? Now, guys, the biggest mistake kids make with factoring is they forget all the other kinds of factoring. You understand what I'm saying? Like they forget they can GCF here. Because they think, oh, I'm doing this new kind of factoring. I don't need any of the old ones. That doesn't make a lot of sense, does it? When you're adding fractions, you still have to remember how to add regular numbers, right? So, any common factors there? Nope. So, what are we going to do? This is the last one I'm going to do, and then I'm going to shut up. Right, so I got to multiply to 12 and add to 13. What is it? 12 and 1. Why did I automatically be able to go plus plus? Because they're both plus and plus, right? Plus 12, plus 1, divide by what? 2, simplify. 12 divided by 2 is 6. That doesn't simplify. N plus 6, 2n plus 1. Check. N times 2n, 2n squared. Yeah, sure, you betcha. 6 times 1, 6. Yeah, sure, you betcha. Everybody good? All right, you've got 10 minutes left in class. On your outline, you guys have it blank. Right? This is what I used to assign. I believe you guys, you seem actually to be picking up on this. So I'm going to shorten this down to page 177. I want you to do number 8. I want you to do 12. I do not want you to do 13. I want you to do 14. And that is it from your textbook. Hey, Mr. Dudoff. I do, indeed. I want you to do that out of your textbook. Should be right in that, to your right, Getting warm, warmer, warmer, on fire. Lick your fingers. Okay. That's where we are from your textbook.
What class is this?
Math 10. All right, from your textbook. Also, I want you to finish page 114, which was the old factoring, right? And I want you to, wrong thing. I want you guys to go down to number 13 from where we are right now. I want you to stop there. Actually, no, I do want you to stop there. No, I lie. Shh. I don't want you to do 14, 15, 16. I don't want you to do 14, 15, 16. Leave them. So I want to come back to them after Monday's stuff. So no 14, no 15, no 16. I'm going to Ghostbuster symbol them. Okay? It is not a lot of work. It looks like a lot of work, but it really isn't. Especially because you're getting 10 minutes right now. Please. Yeah. Carry on. I would like to do a small quiz on Tuesday about just the first kind of trinomial factoring, when a equals 1. Cool? So on Tuesday of next week, which is the 21st, I believe, factoring quiz when a equals 1. Tuesday's the 22nd. Thank you. So that is one of these. Be able to factor that for Tuesday's quiz. Okay? And all the versions of that. What do I mean by versions? If I had 2x squared plus 6x minus 20, be able to factor that, because you're going to take the 2 out, right? Be able to factor if it looks like this. X plus 2 squared plus 3x plus 2 minus 10. Also be able to factor that one. Cool? And of course, Monday's warm-up is going to be all what? These. So you have something written down with exactly the type of questions you're going to need to do for the quiz on Tuesday. Gouda? Great! And have good weekends. In case I forget when the bell rings. I won't. I'll yell it out, but it will feel less personal. So I'm telling you all right now, as I look in all of your faces, have good weekends. I hope you all have big plans. I do not. Although I'm going to try playing rugby for the first time in ages. I haven't played. We are playing in Abbotsford on Sunday if you want to watch the old farts play. Yeah. Noon or 1. I don't know. On Sunday, it's at noon or 1. I think the actual good Abbotsford rugby players are playing on Saturday there as well. But if you want to see the old guys, we're playing at 1 o'clock. What, Caitlin? The young people. Yeah. The old guys are part of the club too. But your brother will be playing Saturday. Why not? Oh, right. I knew that. He had the surgery. I had the same surgery. When's he going to be back? January? Because I got my surgery in August and I was playing again in the next January. Oh, so, yeah, a little later. So if you find yourself with nothing to do and you want to watch a bunch of old people run around, but don't be fooled, it's actually pretty good rugby. Because everybody that's old and plays played at a very high level, except me. Because I only played in Chilliwack. We only had one team. So you had to play for them. Turns out I could have played at a higher level. Because I can play with all these guys just fine. But that would have required going to practice. Who wants to practice? My daughter is going to guide camp this weekend. Her first one. It's not really camp, though, because they're Girl Guides, so they're going to Fort Langley and they're staying in the yurts. Which doesn't really count, as far as I'm concerned. Bye!
We have a Swizzle today.
Oh man! No, we have a Morgenstern.
Oh yeah. I can't believe I'm Morgenstern thing. Actually, no.
What is that? Did you try to make a bird on the side of your head? I'm gonna do some diving. Wasn't that perfect, guys?
I'm gonna read your assignment.
A lot of stuff.
A lot of items in our set.
We did finish work and some notes.
And those actually coffee.
Yeah, because we didn't have to.
Get out of here, Waylon. It's called a Morgenstern. We had one yesterday too. Yes, we had I just go for Do we have a Morgenstern today?
No one.
Was it today?
No, it wasn't.
Yeah.
One in my gym does it. 80%.
Yeah.
I must have something wrong with that. Injured to get shot now.
So you're saying there again? That was my day.
What? Huh? I got my gym class. That sucks.